Ever wanted your Python code to be, well, smarter? Today, we're going to do exactly that. We're going to take two of the most fundamental tools in Python, lists and logic, and combine them to build code that can actually think and react. Let's jump right in.
So this is really the core question, isn't it? I mean, it's one thing to make a program do the same task over and over, but the real magic happens when your code can look at some data and make a choice all on its own.
And here are our key ingredients for today. On one hand, we have lists, which are perfect for holding and organizing all of our data. And on the other, we have if statements, which are basically the decision-making brain of our code. When you put these two together, that's when you get code that can truly adapt to the information it's working with. Okay, first up, let's tackle a super common challenge. How do you get your program to sift through a whole list of items, but treat just one, differently than all the rest? Just imagine you've got a list of products, or maybe usernames, or in this case, a bunch of fruits. How do you actually tell your program, hey, look, when you get to this one specific thing, I need you to do something special?
And you know what? The solution is beautifully simple. We just loop through our list of fruits like we normally would, but right inside that loop, we add an if check. We're literally just asking the program, is the fruit I'm looking at right now a banana? This one simple question creates two completely different paths for our code to follow.
Let's just trace that logic for a second. For every single item in the list, the program pauses to ask that question. Is it an apple? Nope. Okay, print the standard message. Is it a banana? Yes, awesome. Print the special message. It's this simple, repeated decision-making that gives our program a custom, intelligent feel. All right, let's move on to our second scenario, and this one deals with a classic bug that I promise you every single programmer runs into. What on earth should your program do when it's expecting a bunch of data but gets nothing? An empty list? This is a really big deal. If you have a for loop that's ready to process a list of students and that list comes back empty, your program could just crash or start behaving in weird ways. We need a safety net, a way to check if there's any data before we even try to work with it. And this is where Python is just so cool. The solution for this is incredibly elegant. You might think you'd have to check the list's length, right? Something like if len of students greater than 0, but you don't have to. You can just write if students. It's clean, it's easy to read, and it's super efficient. So how does that even work? Well, it's all thanks to a cool Python idea called truthiness. Basically, an empty list, just like the number 0 or an empty string, is considered false whenever you use it in a logical test. Any list with even one single item inside is considered true. So if students is really just a super slick shortcut for asking, hey, is there at least one thing in this list? Okay, for our final example, let's level up the complexity just a little. We're going to tackle a really common real-world task, comparing two different lists to figure out what they have in common. The pizza shop analogy is just perfect for this. Think about it. You've got one list. That's all the toppings you have available in the kitchen. Then, a customer comes in and gives you a second list, the toppings they want on their pizza. Your code's job is to be the chef and compare those two lists. So here's the situation. On the left, we've got our stock. On the right, the customer's order. And you can probably see the problem already, right? They want pineapple, but we just don't have it. Our code needs to spot this mismatch automatically. And here's how we solve it. We loop through the customer's list of requested toppings, and for each and every one, we use this powerful little keyword, in, to ask a simple, direct question. Is this topping in our list of what's available? Let's just walk through what the code is thinking. It picks up pepperoni from the customer's list. It asks, is pepperoni in the available list? Yes, it is. Great, we'll add it. Next, it picks up pineapple. It asks the same question, but this time, the answer is no. So it prints out that sorry message. This membership check is a fantastic way to compare lists. So we've just zipped through 3 really powerful techniques. Let's take a quick second to recap the key takeaways here. So remember these 3 core patterns. To handle that one special item, you use the double equals sign. To safely check if a list is empty, just use the list's name directly in an if statement. And to see if an item exists in another list, that in keyword is your best friend. Honestly, getting these down will help you dodge common errors and just build way smarter, more reliable programs. And really, that's the whole point.
You now have the fundamental building blocks to encode real-world rules and decisions directly into your programs. So the final question is for you. Now that you can do this, what's the first rule you're going to teach your next program to follow? Thanks for watching.